Today we're going to talk about exponent rules, and the first 6 here are just some of the basic exponent rules that you learned in Algebra 1 and you sometimes use in Algebra 2. You don't use very often in geometry, and then here they are, they pop up again in pre-calculus. The main ones, I guess, are the first 3, which are if we multiply 2 terms with like bases, and we add the exponents. So a to the m times a to the n equals a to the m plus n. And consequently, if we divide, then what we do is we subtract. I usually subtract the top exponent minus the bottom exponent when we divide, but you can go the other direction. But I'm going to stick with a to the m divided by a to the n equals a to the m minus n. So multiplication and division, they're inverse operations, so that makes sense. When we multiply, we add, and when we divide, we subtract. A to the 0, any value to the 0 equals 1 is another one, and those are our main ones. There's some power rules down here on 4, 5, and 6. And in general, what 4 says is that a to the m raised to the n means that we multiply those exponents. And if you had me, Mrs. Danhoff, for Algebra 2, I'd like to say that you superpower those. When we superpower, we multiply. The Rule 5 and Rule 6 we don't use too much in pre-calculus, but because we're looking at these exponent rules, it's nice to at least refresh our memories. But what we have inside the parentheses gets raised to the exponent outside. So a gets raised to n and b gets raised to n. And it doesn't matter if you're multiplying those together like it is in number 5, or if we're dividing. What's inside the parentheses gets raised to the exponent outside. A to the n divided by b to the n. So let's do a couple quick examples here. Our first example, x cubed times x to the 4th means that we are going to, because we're multiplying, we are going to add those exponents. And no, you don't need to show that step there, but I want to show it so that if you look back at your notes, you know where that value is coming from. Multiplication, again, we add the exponents. Division, we're going to subtract. So this is going to be x to the 10 minus 2. Again, no, you don't have to show that step, but if you're taking good notes here, then you probably want to write it down, so when you're looking back, you know where that came from. Negative 6x to the 0 here. We want to specifically look at x to the 0. I didn't do very well circling that, but we want to look at x to the 0 first. And x to the 0, if you look back at our rules above, what you can see on your paper, x to the 0 is 1. And then we're going to multiply by negative 6. So our answer in this particular case is negative 6. Only the x to the 0 equals 1. And then we need to multiply by negative 6. Finally here, 2x to the 9th times 5x squared. When we multiply, we're going to multiply the numbers together, so it's going to be 2 times 5. And we're going to multiply the variables together, x to the 9th times x squared. 2 times 5 is 10. And once again, when we multiply variables with exponents, we're going to add the exponents. So we get 10 x to the 11. Some other rules that maybe you struggled with a little bit more are the negative exponent rules. And here they all are listed. First of all, on number 7, a to the negative n equals 1 over a to the n. And what I'd like to say is that we can write a to the negative n over 1, and then we flip and change the sign of the exponent. If you want to get technical, we should be saying taking the reciprocal of this and changing the sign of the exponent, but I oftentimes say flip and change the sign of the exponent. Works the same way here on number 8. we flip and change the sign on the exponent. So we end up with a to the n over 1. And when we have a fraction already, we're still flipping, taking the reciprocal, and changing the sign on the exponent. Let's do a couple of examples with those, even more than a couple. If we take a look here at number 1, we want to simplify and write our final answer with positive exponents. Well, it's x to the negative 4. And what we're going to do is we're going to flip this. And when we flip it, we change the sign on the exponent. That's all we have to do. Number 2, same kind of idea. We're going to flip and change the sign on the exponent. So this becomes x cubed over 1 because I flipped it and I changed the sign on the exponent, and we don't really need to write the 1 in the denominator. And some of you who are working ahead probably just have x cubed, which is fine. We flipped it, changed the sign on the exponent. Now we're going to, number 3, deal with division in here. And again, there's a couple ways to approach this, but I like to stick with my division method, which is simply to start with saying, well, this is x to the 3 minus 7. When we divide, we subtract. And I usually subtract the top exponent by the bottom exponent. This gives us x to the negative 10. But then if we look back at problem number 1, what we see is when we've got x to the negative 10, we need to flip and change the sign on the exponent. So this finally becomes 1 over x to the 10 in positive exponent form. If we're following the directions, writing our final answer with positive exponents only. Number 4, when we take a look at this one, 2x to the negative 5th, keep in mind that this is 2 times x to the negative 5th, because the only part that's flipping is the part that has the negative exponent. So x to the negative 5th is going to flip and change the sign on the exponent. That means it's going to move down here to the bottom if we write it like that. So we flipped it, changed the sign on the exponent. Well, the 2 is still there. So we end up with 2 over x to the 5th. If I do a little bit better with showing my work here, what we end up with is we end up with 2 times 1 over x to the 5th. And remember, when we multiply exponents, we multiply the top. Sorry, when we multiply fractions, we multiply the top of the fraction together. 2 times 1 is 2. And we multiply the bottom of the fraction together. 1 times x to the 5th is x to the 5th. A little bit better there in terms of explanation. And then on our last one, it's the same kind of thing. Only flipping and changing the sign on the exponent with this variable of x. 5 doesn't have a negative exponent. 4 doesn't have a negative exponent. Only the x has a negative exponent. So what's going to happen is that the 5 is going to stay in the same place. The 4 is going to stay in the same place, but the x to the negative 2, we're going to flip it. So it's going to move up here to the numerator, and we're going to change the sign on the exponent. One last set of rules for exponents. They are rational exponents. Remember that a rational number is any number that can be written as a fraction. And what we say with this, and this may be new for some of you, is that we can rewrite this fraction exponent in terms of radicals. What happens is that the a is going to be the value underneath the radical. The denominator of the fraction is going to go in this check mark part of the radical, and then our numerator can go right there. The nice thing is that it's a 1, and a to the first is still 1. And I'm going to erase and try to write this just a little bit better. It didn't show up very well when I wrote. But again, a goes underneath the radical, and the n goes in the check mark part of the radical. A is called the radicand, n is called the index. We may or may not use that terminology. But that's nice when there's a numerator, the top of the fraction is 1, but we sometimes don't get just 1 over some number. We might have a complete fraction here, a to the mn, and what happens is that the a still goes underneath the radical, and the denominator still goes in that check mark part, and then the numerator. We can write it here, where it's a to the m completely underneath the radical, or sometimes if you're doing these problems by hand, you can solve them a lot easier if you figure out that value and then raise it to the exponent of the m. Either one of those will work for us. And these, again, for some of you, you've seen, and for some of you, you may not have seen. But let's take a look at a couple of examples, and before we get too involved in them, I just want to practice writing them in radical form. Well, x to the 1/3. Again, the x is going to be the value that goes underneath the radical. The denominator of the fraction exponent goes in the check mark part. And the nice part is that there's a 1 on this one. So we don't even need to really write the 1. X to the 1/3 means the same thing as the cube root of x. Now on number 2, we've got 2/5. So that's going to fall into our second category there, the x to the mn. But again, it's not much difference. The x goes in the denominator. Sorry, the x goes underneath the radical. The 5 goes in the check mark part of the radical. And then we can write the 2 underneath the radical, or we can still have the 5th root of x, but then we could write the 2 outside the radical. Obviously, it looks like it's a little bit cleaner if we do write it the first way, but sometimes when we're actually figuring out a value, it's easier to write it the second way. Number 3, we've got a negative exponent in here, and before we even get started, let's deal with that negative exponent. And negative exponents mean that we're going to flip and change the sign on the exponent. So this is going to become 1 divided by x to the 2/3. And then after we get that, then we can rewrite this part as 1 over the x. It's going to be the value underneath the radical. The denominator of the exponent, the bottom of the exponent, is going to go in the check mark part of the radical. And then once again, we can put our 2 here, or we could write it outside of that. And in terms of this, I'll write it. Or it could be this, 1 over the cube root of x, and then squared. So that's just a little bit of the basic. I put a few more examples on here of this because many of you have not worked with this before. Sometimes we're given a radical and we need to go the other direction. We want to write the radical as an exponential. So we want to write it with exponents here. And the one thing that we need to know is that when there's nothing written in the check mark part of the radical, it's a 2. A very small 2 there that I just wrote down. But 10, a number underneath the radical in this case, is going to be the base. And remember, whatever number's in the check mark part of the radical is going to go in the denominator. We don't have any exponent on the 10, so it must be 1. So the square root of 10 is the same thing as 10 to the 1/2. Number 5, same idea here. We need to know that when there's no number written in the check mark part, it's a 2. And we don't have to write it down, but for some of you, that might be a good idea, especially if you're very visual. When we rewrite this, the x to the 9 is what's underneath the radical, and our denominator is coming from the value in the check mark part of the radical called the index, and it's going to be 9/2. Number 6, same idea. What's underneath the radical? We'll start with that. X to the 6th. Then what's in our check mark part of the radical? That's 3. That's going to be the denominator. And x to the 6 over 3 really simplifies to be x squared in this case. As we get close to finishing, write the exponential in radical form, and then evaluate. So I know some of you, your inclination is to go directly to the calculator and just type this in. But the idea here is to familiarize yourself with what it means to work with a fraction exponent. When we look at this one, write the exponential in radical form. Well, this is going to be 144. The 2 in the denominator goes in the check mark part, but I'm not going to write it. Because what does the square root of 144 equal? Most of you know that already from your quick recall in Algebra 2. And it's 12. Number 8, 16 to the 1/4. Again, first of all, write it in a radical form, and then evaluate the value of this. So we're going to rewrite it. Square root, nope, not square root, but we're going to put the 16 underneath the square root symbol. But the reason it's not square root is because the denominator of the fraction exponent is a 4, and we do need to write the 4 in our check mark part of the radical. And what we want to know now is, well, what does the 4th root of 16 equal? And just a reminder here that 16 is 4 times 4, which is 2 times 2. And here is 2 times 2. And what we're looking for is we're looking for 4 of the same value to take out 1. The 4th root of 16 is 2. A couple more. Again, many of you haven't had the even seen this concept before. But first of all, rewrite the exponential in radical form. The 8 is going to go underneath. In this particular case, we have a denominator of a fraction of 3. And then there's a couple ways to do it. We can put the 2 here. So if we simplify that a little bit more, 8 squared is 64. And then what we're looking for is we're looking for 3 of the same value to take out 1. And if you go about the same way that I did problem number 8, 64 is 8 times 8, which is 4 times 2, and 2 times 2. I'm going to carry that 2 down. Same thing over here, 4 times 2. 2 times 2, and if we write these 3 down with our other 3, once again, what we're looking for is we're looking for 3 of the same value, and 3 of the same value gives us this, and 3 of the same value gives us that. When 3 of the same value, we can take out a 2. 3 more of the same value, we can take out another 2. And 2 times 2 is 4. Now, obviously, for some of you, you're thinking, do I really have to do all of that? I know that's the long way. Some of you are going to type it in your calculator. But make sure that you know how to rewrite 8 to the 2/3 power in terms of radical. Last one here. In this section, before we get a few miscellaneous ones to finish up, 32 2/5. We are going to write this as a radical first. 32 is going to go underneath our radical. The 5 is going to go in the check mark part. And I'm going to go the other direction this time. 5th root of 32. Well, if you think about it, what we're looking for is 5 of the same. Some of you are going to use the math button on your calculator. But the 5th root of 32, remember 32 is 4 times 8, which is 2 and 2, and 8 is 2 and 2 and 2. So the fifth root of 32 is, actually equals 2, and then squared. Clearly, I like to do these problems without using a calculator, which is why I do some of this long work with the radicals. Some of you already know that the fifth root of 32 is 2, and you don't need to spend that time. But for those of you who don't have a calculator, that might be helpful. But to finish this one, the fifth root of 32 is 2. 2 squared equals 4, and that's what 32 to the 2/5 power equals. Finally, if we mix it up here on these last few, we've got x to the 1/2 divided by x cubed. And so we've got to go back to that division rule, and remember with the division rule, we need to subtract. The nice thing is, when we look at our directions, we do want to simplify, but in this case, what it says is, write your answer with the negative exponent, and write your answer with a positive, and I should have put positive exponent instead of positive answer, but here we go. When we divide means that we subtract exponents. So one of the issues for people is that we do have fractions here, but 1/2 minus 3, you can type it in your calculator. You can find a common denominator, and 6/2 is the same thing as 3. Well, 1/2 minus 6/2 gives us x to the negative 5/2. There's when we wrote it with a negative exponent. So how do we write this with the positive exponent? Well, positive exponent means that we flip. There's the flip. And then we change the sign on the exponent. So now it's going to be 1/5 squared. Number 12. Same idea here. X to the 4th divided by x to the 3/2. Well, when we divide, we subtract. So it's going to be 4 minus 3/2. Once again, some of you are probably going to type in 4 minus 3/2. But the other way to do this is to say that 4 is the same thing as 8/2 minus 3/2, because when we add or subtract fractions, we need to find a common denominator. So we end up with x. 8 minus 3 is 5/2. Just coincidence that we ended up with the same exponent there with the 5/2. But there's a positive exponent. How can we write it with a negative? Well, we can still flip and change the sign on the exponent. Now, 13 has radicals in it. But remember, we just practiced writing these problems with radicals. With fraction exponents. So let's convert it. The cubed root of x is going to become x. The denominator is going to be the 3, the number in the checkmark part, x to the 1/3. Down here, the square root of x. Remember, and I can't possibly write it small enough, but the number in the checkmark part of the radical is a 2 when it's not written. So this becomes x, 2 goes in the denominator, and it's 1. So once we get it written back here in the format with the fraction exponents, then what's going to happen is we're going to divide, just like we did on 11 and 12. So this becomes x to the 1/3 minus 1/2. Well, when we find a common denominator, we've got 6. And when we subtract, 2/6 minus 3/6 gives us negative 1/6. So there's our negative exponent. And then we can rewrite it with our positive exponent. Once again, we're going to flip and change the sign on the exponent. 1/x to the 1/6. Two last ones. Simplify. Write our final answer with positive exponents. So we mixed it up here. We've got x to the 6th times the square root of x. But we just talked about what we do there with the square root of x. We know that it's got a 2 in that checkmark part. So this is x to the 6th times x to the what's in the check mark part is going to go in the denominator. So that 2 is going to go in the denominator, x to the 1/2. When we multiply exponents, we add the exponents. So this is going to be x to the 6 plus 1/2. If we need to, we can rewrite this as 12 over 2 plus 1 over 2. And we end up with x to the 13 halves. Same idea over here with problem number 15. Still have a 2 there in that check mark part. So this is going to be x to the 1/2. When we convert the cubed root of x squared to a fraction exponent, we're going to get x to the 2/3. Notice the number that's in the check mark part of the radical goes in the denominator of the fraction. When we multiply, we add the exponents. And then when we add or subtract fractions, we need to have a common denominator. So this is going to be 3/6. This is going to be 4/6. And we end up with x to the 7/6.